All right, Kim Shepard again. Welcome back. We're going to do video 11G. We're going to talk about conditional probability. So we kind of did a couple of these at the end of the last video, but let's solidify this concept a little bit more. So the probability of event B occurring, if we know that event A has already occurred, is a conditional probability. We have this condition, we know A has happened. If we know A has happened, what's the likelihood of B? How we denote that? This is the probability of event B given, you already know, event A has happened. So we read this as the probability of B given, that line sort of reads as given A. This is the event that you know has happened. This is the event you're trying to find under that condition. All right, we have a rule for computing conditional probabilities. And so the way we compute the probability of event B given event A has happened is you look at the probability that both A and B have happened. We'll write both. And you divide by whatever condition you know. The probability, whatever event is over here that's known to have happened, that's what goes in the denominator. So if this said the probability of A given B, be careful, you know, which item we're trying to find and which one we know is important. It's whichever one we know is what goes down in the denominator. In this case, we know event A has happened, so we're going to divide by the probability of event A. All right, let's look at a few problems that use this rule. All right, in your notes, you have a table. This is a table for Cecil College students, and you have a contingency table. We have recorded whether or not the student's a nursing student, and then the student's gender. And then we have totals for some of these. So at Cecil College, we have this data was collected. Compute the following probabilities. We want to know the probability a student is male, that's what we're trying to find, given we know they're a nursing student. So this is what we know about them. And if we know they're a nursing student, find the probability that they're male. All right, if we apply that formula, this is the probability that a student is male and a nursing student. Divided by the condition that's known. It's known that this student is a nursing student. So now we just need to find these two probabilities and take the top one divided by the second one. So okay, what is the likelihood if we randomly pick a student that they're a male and a nursing student? So just look at the numerator. There are 400 students total. Out of those 400 students, let's find out how many are male and nursing. Male and nursing students. There are 3 out of 400 students in this table that are male and nursing students. So this would be the likelihood of selecting a male student and the nursing student, a student that's male and nursing. In the denominator, we need the likelihood that a student's a nursing student. Nursing student. There are 32 nursing students out of the 400 students in this table. So the likelihood of selecting a nursing student would be 32 out of 400. Now we need to divide these. Hopefully you remember from algebra, dividing two fractions. You can multiply by the reciprocal of the denominator. When you do that, those 400s are going to cross out. And we'll get 3 out of 32. If you write that in its decimal form, we get 0.09375. Let me pause here for a second. Sometimes there are multiple ways to do these problems. If we look here, we could have said, hey, we know we're only looking at nursing students. So instead of looking at all 400 students in the chart, how about if we only look at the 32 nursing students? And out of the 32 nursing students, how many of them are male? There were 3 males out of the 32. So you could do this problem that way as well, and you end up with the same answer. All right, part B. What's the probability that we select a male student if we know the student's not a nursing student? So we have a different condition that we know here. This is the probability we select a male student and they're not in nursing. Divided by the known condition. The known condition is that they are not a nursing student. Again, I'll do this one 2 ways. The likelihood of selecting a male student and a student that's not a nurse, male and not a nurse, there are 129 of them out of the 400 students. In the denominator, the likelihood of selecting a student that's not a nursing student, there are 368 students that are not nursing students out of the 400. When you multiply by the reciprocal of the denominator, those 400s will cancel out. We'll get 129 out of 368. You may have written this down. You may have said, hey, the condition that's known is you are not a nursing student. We are only looking at these 368 students that are not nursing students. We know for sure it's not a nursing student. If we know for sure it's not a nursing student, what's the likelihood of selecting a male? Well, out of those 129 are males. So you could have written that down too. If you divide that out, this is about 0.3505. All right, a couple more. This one's not conditional. Part C is just what's the likelihood if you select a student that you get a male. Okay, so out of all 400 students, what's the likelihood we select a male student? Males, there are 132 male students out of the 400. If you take 132 out of 400, it's about a third. We get a probability of about 0.33. All right, 2 more. These are conditional. What's the probability we select a nursing student if we know the student's a male? So what's the likelihood of selecting a nursing student given if you know that this student is male? Again, this is the likelihood of both of those, nursing and male, divided by the condition that's known. This time, it's the gender that's known. It's known that you've selected a male student. One more time, I'll do probabilities. The likelihood of selecting a nursing and male student, nursing and male, there are 3 students out of the 400 that are in nursing and males. The likelihood of selecting a male student, we just did. There were 132 out of 400 students that are males. If you multiply by the reciprocal of the denominator, we'll end up with 3 out of 132, which you may have written down to begin with. If the condition that's known is that it's a male student, we're only looking at these 132 students to begin with. Out of those, what's the likelihood of selecting a nursing student? 3 out of the 132 are nursing students. And again, as a decimal, we get about 0.0227. Okay, one more. What's the probability of selecting a nursing student if we know we have a female? again, this is the likelihood of nursing and female divided by the condition that's known. This time we know that the student's a female. And I'll do this one by just looking at the numbers this time. We know that you've selected a female student. If that's the case, we're no longer looking at all 400 students. We're only looking at the 268 students that are females. And out of those, how many are in nursing? So out of the 268 females, 29 of them are nursing students. And so here we would get a probability of about 0.1082. All right, we got one more question to wrap this up with conditional probability, and this ties this conditional probability into independence. So let's look at part F. Comment on whether or not gender and are you a nursing student, are they independent, and support those with probabilities. Okay, so I've erased some previous parts here, but let me just quickly jot down some of the probabilities that we got from A, B, and C. In A, probability of a student being male, if we knew they were in nursing, was 0.09375. From B, the probability that we select a male if we know the student's not a nursing student, that was 0.3505. And then finally C, the probability of selecting a male student under no conditions, that happened about a third of the time. All right, so I'm going to use these results to comment on whether or not gender and nursing student, if those are independent or dependent. If gender and being a nursing student were independent of one another, then you would expect that if we knew a student was a nursing student, about a third of them would be male. If we knew a student was not in nursing, about a third of them would be male, since about a third of Cecil students are males. In this case, it turns out that if you know a student is in nursing, the probability of selecting a male student is quite substantially different from a third there. If you know that they're not in nursing, that's a little bit different from a third, but in particular, this is much different than the likelihood of overall selecting a male student. When they're independent, then it would mean that, hey, this condition really doesn't matter. You ought to get about the same probability, whether you know something about that student or not. If nursing and male were independent, all of these probabilities would be about 1/3. So in this case, your gender clearly affects whether or not you're a nursing student, or vice versa, you could say as well. So in this case, these are dependent. Let's say 33% of students are male. But only 9.375% of students are male if we know that the students are in the nursing program. That's a big difference. And again, if they were independent, wouldn't matter whether you're in nursing, not in nursing, across the board, it'd be a third of students are male in any department. That's not the case, and so therefore gender and are you a nursing student in this example are dependent. Okay, and that's it for this video. See you in class.